Okay, actually, I accidentally cut the last video off, but I was supposed to actually talk about one last thing, and that's sonar. So, newly developed sonar technology, okay, actually led to the discovery of underwater mountain ranges and deep ocean trenches. Okay, sonar is basically an acronym for sound navigation ranging. It uses sound to navigate. So it basically uses echoes sound, right? It uses echoes from the ocean floor to measure ocean depth. Okay, and if you can measure ocean depth, then you can measure, say, how high a mountain range is, for example. Okay, so let's say you've got a boat on water and you send pulses, right? Echoes. And if there's an object, you get an echo back, and also it'll take less time for the signal to travel from the water or from the boat to the back to the boat. Okay, why? And how can you tell if there's a mountain range? Well, and deep trenches, because of this principle, right? The less time it takes, the more, the bigger the object is under the water, the higher it is, right? And it basically, sonar systems use what's called a phagometer. Okay, I've seen this on boats actually. It's a device used to measure the depth of water, right? And it measures the time it takes for a sound pulse to reach sea bottom and return to ship. That's the basic principle. So the time it takes to go down and go back up. Okay, fishing boats use this to locate schools of fish, right? For fishing purposes. So that's that. Let me now talk about natural disasters. Okay, I want to talk about earthquakes. Okay, by definition, what are they? Okay, rapid movement of ground. Okay, usually back and forth and up and down in a wave motion. Okay, it's caused by the rapid release of energy as tectonic plates move. That's an earthquake. Okay, here's another way to put it: caused by a rapid release of energy as tectonic plates move. Okay, that's an earthquake. Now well, not me actually. Scientists measure earthquakes using an instrument called a seismometer. Okay, seismometer. That's what they measure earthquakes with. Okay, and waves in the earth caused by an earthquake are actually called seismic waves. Okay, waves that travel through the earth as an earthquake, seismic wave. Okay, that's why it's called a seismometer, where you measure them with. There are actually three main types of seismic waves. Okay, you've got to know these types. Not that hard to remember. Three main types of seismic waves. Okay, number one, you've got primary waves. Primary waves, or P waves for short. Okay, these are longitudinal waves. Longitudinal waves that travel fast through the earth. Okay, remember, longitudinal is left and right, moves left and right. So this is the earth, let's say, part of the earth. These move left and right. And these move fast. Number one. Number two, you've got secondary waves. Okay, or S waves for short. These are transverse waves. And they travel slightly slower than P waves. Okay, here's how you sort of remember the two. Think of primary as being the best, right? Secondary, the primary as in the best, the fastest, the strongest. Secondary waves not so strong. Okay, primary means the main one, right? The main type of seismic wave would have to be the fastest, right? The strongest. That's number two. Number three, you've got surface waves. And as the name suggests, these are waves that travel on the surface of the earth, right? These are the slowest of the three waves. Slowest waves, and they cause the most destruction. You do not want to be anywhere near a surface wave, that's for sure. Show you on a diagram. Let me show you on the diagram what a typical pulse, seismic wave would look like on a seismometer. Or a seismograph, it's actually called a seismograph, I believe. Seismograph. I think that's how you spell it. Okay. You've got something like this. So you've got the P wave being here. You've got the S wave being here. And then you've got the surface wave being here. Okay, it causes the most destruction, right? Transverse is the second. Well, why isn't it primary and then secondary? Well, because remember, seismic waves are transverse waves, and transverse waves move up and down. They cause more damage than left and right, right? These can cause a building to collapse, whereas the left and right can just cause it to shake, right? So S waves, should mention as well, S waves and P waves, they travel deep, they travel in the earth, travel deep under the ground, and then they bend upwards to reach the crust surface. Okay. P waves, okay, shake the ground up and down. S waves, shake it left and right, okay? And nearly all, I should also mention that nearly all earthquakes start at the edges of tectonic plates. Okay, the strongest earthquakes occur near the converging boundaries, right? So converging boundaries, remember these are when, as I mentioned before, two plates come together and you get a slamming and then you get vibrations, right? When two things collide, they cause vibrations, they cause waves. And now this distribution also provides further evidence to support the theory of plate tectonics, right? Because it shows that this theory works, of plate collisions. And that's earthquakes in a nutshell. Let me now talk about tsunamis, the very last thing for this topic, actually. And the word tsunami is actually Japanese, if you haven't already realized. Okay, it's by definition, it's an earthquake under ocean that occurs in the ocean, causing a huge wave. Okay, it's an underwater earthquake. Now, when the ocean floor at a plate boundary rises or falls suddenly, okay, it displaces, okay, so it moves, displaces the water above it, and it launches it, it launches the rolling wave. That'll become a tsunami, okay? Now, most tsunamis are actually, so about 80% of them happen to occur in the Pacific Ocean, right? It's not so surprising. And they can also be caused, by underwater landslides. Okay, landslides is when massive amounts of mass start moving downwards. So there's a big pole, and some of that pole starts to move downwards, hits the floor, and then that sends shock waves up, and you get waves. Underwater landslides or volcanic eruptions. Okay. Well, because underwater, if you've got a volcano, launches stuff into the water starts to move up and down, you get waves. Now, and once again, evidence for plate tectonics is from tsunamis, right? Because earthquakes are generated in a subduction zone area, okay? Where an oceanic plate is being forced down into the mantle by plate tectonic forces, right? So if I draw a plate here and another plate here, a bigger plate, this plate will sink, this plate will rise, that'll cause motion up and down, that'll cause waves, and you'll get a tsunami. So that's tsunamis in a nutshell, and that concludes this unit, continents on the move.